Hi everyone, I am Arhan İlhan and here is my Physics 211 project. Wave Focusing and Convergence, investigating the dynamics of water wave concentration at a focal point. Firstly, theory. Dispersion relations explain the relation between the angular frequency and the wave number of a wave. In water waves, this relation is given as omega squared equal to g times kh times tangent hyperbolic kh. Since we are using shallow waters, this simplifies to omega equals k times square root of gh. Therefore, the speed of the wave propagation is given to be square root of gh, and for our setup with a water depth of 1 centimeter, this comes out to be 0.31 meters per second, which is really close to the values obtained experimentally. Rayleigh criterion and diffraction limit explains the minimum resolution that can be obtained for an aperture like ours. Since we are using a circular aperture to focus points on a single point, the resolution is really important. Therefore, the minimum focal width that can be obtained comes out to be 2 centimeters for our setup. When 2 point sources are placed on a 2D system, an interference pattern with antinodal and nodal lines emerges. For a point to be on an antinodal line, the distance difference to the two sources must be an integer multiple of lambda. On the axis of the 2 point sources, when a point moves by half a wavelength, the distance difference changes by a wavelength. Therefore, the distance between two adjacent antinodal lines or two adjacent nodal lines are half a wavelength. Here is our experimental setup with a large water tank, a vibration motor, a power supply, cotton to absorb reflections, and a lamp. Here is our experimental source configurations. Single point source. Here's a demonstration of the single point source. An analysis line with minimal background noise was chosen. With image processing, the individual frames was extracted from the video and frames that exhibit similar intensity profiles was chosen. The mean and the standard deviation of these intensities was calculated, and the mean plus and minus one standard deviation and a fitted sine wave was plotted. As can be seen, the waves exhibit a sinusoidal behavior. 2 point source. Here's a simulation of the 2 point source to understand what to expect from our experiment. Here is the demonstration of our experiment. As can be seen, the nodal and the antinodal lines are clearly visible. An analysis line was chosen as such, and the average intensities along the analysis line for all the frames was plotted. As can be seen, the distances between the peaks came out to be 0.9 centimeters, which is exactly half of the wavelength. This was predicted by theoretical calculations. Planar source. Here's a demonstration of the planar source. An analysis line was chosen as such, and for the analysis, a similar procedure was followed as the first setup. As can be seen, the waves exhibited a sinusoidal behavior. Curved source. Here is a simulation for the curved source. The simulation shows that the focal length is achieved at approximately 16 centimeters, and the width of the focal region is approximately 2 centimeters. Here is a demonstration of our setup. Experimentally, we have achieved a focal length of 16.5 centimeters, and the width of the focal region came out to be 2.67 centimeters, which is close to the values obtained from the simulation. Therefore, we have achieved wave focusing. Thank you for watching.